I've always wondered why the value of E is approximately equal to 2.71. After a lot of inquiry, I found out that 2.71 or E is the upper ceiling limit of rate at which anything growing on the rules of compound interest can grow. But for that, first we need to understand what is compound interest. If compound interest is put on steroids, 2.71 or a rate of 2.71 is the maximum ceiling, is the maximum rate at which something can grow. Beyond this rate, compound interest as if gets limited by nature itself. So let's moving into understanding what is compound interest first. So let's see compound growth. Compound growth can be calculated as, that is the amount that you get after compounding, equals to the principal amount that you are putting in a bank plus a fractional amount of increase that comes as the interest. These two are summed up and it is raised to the total number of intervals in which compounding happens. You might have heard that when you put money in a bank, the compounding happens after 3 months or 6 months or 1 year. So it depends. So let's say you have put money in a bank and the bank is such that it gives an interest of compounding twice in a year. So in that case, after 1 year, the number of intervals will be 2. So for any given period of time, the number of intervals for which compounding has happened is what is written here. This is the principal amount, whatever you put into the bank. This is the amount of interest that you get after compounding, raised to the total number of intervals in which compounding has happened. For example, let's take an example in which the principal amount is $1. That is, you have put $1 in the bank. The interest that you are getting is $0.3, that is 30 cents, and the number of intervals that have passed in which compounding has taken place is only one. That is, only one interval has taken place in which you have got an interest of 0.3 for every $1 that you have put. So the amount after compounding is equal to $1 plus 30 cents, the whole raised to 1. So the total amount is equals to $1.3. Now let's take other examples. Now for the same example, let's say the principal amount is $1 and interest is 30 cents. But let's vary the number of n. You want to get more and more intervals in which compounding has happened so that you get more and more compound growth. So for n equals to 1, you get $1.3 as shown in the previous page. Now let's take n equals to 2, that is 2 intervals have passed by in which compound growth has happened. So now the growth is $1 plus $0.3 raised to 2. So now instead of $1.3, you are left with $1.6, because here the n was 1, here the n is 2. Now let's see what happens for n equals to 3. It becomes $1 plus 30 cents raised to 3. So now you are left with 2.197. This means the more you increase the number of intervals in which compounding happens, you get higher and higher numbers. If the number of intervals is 1, $1.3. If the number of intervals is 2, you get 1.6. If the number of intervals is 3, you get 2.197. Now Let's take compound interest on steroids. Let's put compound interest on steroids, that is, let's increase the number of value of n such that you get more and more and more compound interest. Let's say someone decides to do that. Someone becomes greedy. So let's say we try to increase the final amount by increasing the number of intervals in which compounding takes place, increasing n infinitely, increasing n as far as possible. So now the final growth equals to principal amount plus interest, the whole raised to keep increasing the value of n. This is what you're doing. Everything else is the same. It's just that you are going to increase the knob of n, as if there's a knob here which you can turn, and instead of keeping the n as a small number, you're going on increasing it. Now, will the rate of compound growth also grow infinitely? That is, will the rate of interest grow like this on a graph, vertically? The answer is no. Why does this happen? Why can't compound growth grow infinitely? Why can't money keep reproducing itself by compound interest up to infinity? The answer is that what exactly happens in this case is that as you keep increasing the value of n, as you keep increasing the number of intervals in which you keep getting interest from the principal amount, that is, the principal amount keeps reproducing itself, and that is how you keep getting the interest. For example, in the example that I gave, where $1.30, it is out of the $1 that grew that you got 30 cents. The $1 as if reproduced itself like an amoeba and split into $1.30. That is how you got the interest. But when you reduce the time for which as you keep on increasing the intervals for n, the newly born baby keeps reducing in size. For example, if you increase the value of n to 3, the value of the interest becomes 1 by 3. It's a direct inverse proportion. So $1 plus 1 by $3 raised to 3. So what you get is 2.37. So let's say now you increase the value of 10. You turn the knob of n equals to 10. So when you turn the knob of 10 here and you try to increase this, unfortunately for you, nature as if puts a limit, a ceiling, and says you can't go greedy. If you increase this by 10, I'm going to reduce this by 1 by 10. So first you are getting 1/3 of interest for n equals to 3. Now you are getting only 1/10 of this when you are increasing n to 10. So when you increase this to 10, this becomes 1 by 10. You increase this to 3, this becomes 1 by 3. You increase this to 1000, it becomes 1 by 1000. You get only 1000 of this. The more you get greedy here by increasing this, the more nature tries to compensate it by reducing this. Okay, it says you want to increase the intervals in which the money is growing. I will reduce the amount that you get after each interval. You increase the intervals, I will compensate it by reducing the amount that you get after each interval of splitting. And if you carefully see, it approaches 2.71825. The higher, the more greedy you get, the more it reaches 2.71825, and this is the limit. It keeps growing up to a certain limit. The more you keep getting greedy, up to a certain limit, as if nature allows you to get greedy. From 2.37 you came to 2.59, you came to 2.7, but The moment you reached a high enough number like 50,000, it became 2.71825. This is the limit. You can't grow from more than this. So now let's look at summarizing the whole thing. For compound interest, the final growth equals to principal amount plus interest added, the whole raised to the number of intervals of compounding. If you try to grow compound interest by getting greedy infinitely, it won't work. You actually try to grow compound interest usually by increasing the knob on this. This is like a knob, you keep increasing it. So when you try to increase the knob here, that is the number of intervals of compounding, the amount that you get after every compounding keeps reducing. Nature keeps reducing the knob here. So the final growth becomes a constant. These two are inversely proportional to each other. And growth will stagnate at 2.71825 approximately as n tends to infinity. That is, as you keep turning this to infinity, this converges, the number of growth converges to 2.71825. So growth equals to principal amount plus 1 by n, and here n tends to infinity, yes, that's it. Now there's something more. There's an additional note. In the formula, final growth equals to principal amount plus interest added raised to the number of intervals of compounding. The principal amount in reality will always be written as a fraction 1 by 1. So don't add a number like 3 or 4 here. In the example that I gave, I deliberately gave it as $1, but in reality, in real life, don't add a number like $4 or $5 there. In reality, the principal amount is expressed as a fraction 1 by 1, which means full of full. 1 by 1, this ratio means full by full. That is, the full principal amount is there as it is. It means whole. Just as 1 by 2 in maths means half of full, 1 by 3 means 1/3 of full, 1 by 4 means 1/4 of full. Instead of this, it is 1 by 1 that is written, which is like a representative that the entire amount is there. The principal amount is kept as it is, untouched. It is not reduced to half. Nothing has been done to it. So 1 by 1 means full of full, and that is what is written here, but we loosely write it as 1. This was a huge confusion for me. Whenever I used to see 1, I used to literally take it as the number 1. That means 1 apple, 1 mango, 1 orange. No. In the formula, the actual formula of final growth is like this: 1 plus 1 by n raised to n. The 1 here is not $1. It's not necessarily $1. It can be $3, it can be $4, but 1 actually means full of full. That is the $3 kept as it is. And to the $3 kept as it is, 1 upon n is added. A quantity is added to the full. This means 1 upon 1 plus 1 upon n. It's a ratio, and ratios are always representatives which signify something. For example, 1 by 2 is a ratio. It represents half of full. It does not necessarily mean 0.5 kg. So that is what it is. Similarly, 1 by n is another ratio. It signifies a portion taken off from the full. Are you getting me? From the full, a portion more is added. That is, if there is $1 or $10, another quantity is added to this $10, and that quantity is $10 divided by n, whatever the value of n is. N can be 2, n can be 3, so on. So it is 1 by n. 1 by n means another quantity is added to it, and this quantity is such that its value is the full 1 by 1 divided by n. So that is how this formula is written. So it is 1 plus 1 by n, the whole raised to n. So once again, in math, the fraction 1 upon 1, or loosely written as just 1, means full of full, just as half means half of full, 1/3 means 1/3 of full, and so on. So that is all from my side. Whatever you are seeing here is an excerpt from a book called as Visualizing Maths, and the link to the book is given in the description below. So that is all from my side. Thank you.